world's longest transoceanic bridge across China's Hangzhou Bay is a monumental task. To overcome extreme weather and complete the bridge on time, the construction team have developed some radical solutions, including building the enormous girders on land. But weighing in at a colossal 2,200 tons, the girders are the Goliaths of the prefabrication process. Moving them from the factory to the construction front will be a logistical nightmare. Deep water on the north side of the bay means that construction materials can only be transported to the work front by boat. For the workers and their supplies, this doesn't present a major problem. Behind girders, they're going to need some truly awesome lifting power. This mighty machine must be able to position the enormous girders accurately onto the 40-meter-high piers, while coping with the swift currents of Hangzhou Bay. The answer? The Tianyi, a giant floating crane powered by a 4,800 horsepower engine. Tianyi means #1 in the world. At 93 meters long and with a displacement of 11,000 tons, it's easy to see why she got the name.
The capacity of this machine can reach 3,000 tons. The lifting height can reach 53 meters.
She will need every ounce of her incredible size and power as she takes on the bay. As the Tianyi carries the girder out to sea, the mists create a false sense of calm. But beneath the surface of the water, the battle has already begun. Extremely swift currents rip through Hangzhou Bay, the fastest reaching a staggering 5 meters per second. At that speed, a boat has to do almost 10 knots just to maintain its position. Even the fishermen who call the bay home struggle with the fast-moving water that changes direction with every tide.
In my opinion, the biggest challenge is overcoming the fast currents. If you take a boat to the fast current zone, after you've seen the current, you would feel quite scared.
Out in the bay, the crew struggles to maneuver the giant ship into place. The rapidly moving water is a real menace when the girders must be lifted up and onto the piers with millimeter accuracy. Anchors hold the Tianyi in place. Then the crew winch the ship to the exact position. The crane can now lower the girders safely onto the piers. Once in place, the workers release the cables from the girder, freeing the Tianyi. But the Tianyi can't be used on the other side of the bay. On the south shore, the water's too shallow. Tidal mudflats extend for 70 kilometers along the coast and 10 kilometers out to sea. At low tide, virtually nothing can move in this quagmire, except the odd clam harvester. Even at high tide, the mudflats are a no-entry zone for large construction. The team can't afford to get bogged down at this stage. They'll have to come up with a creative solution. Once again, the engineers rise to the challenge. To install the enormous girders, the team develop a specialized truck, stronger than anything that has come before, and a machine that defies gravity. And it all starts with a whole lot of wheels. The TE1600 is a 640-wheeled vehicle specially designed to carry the giant girders from the factory to the construction front.
By carrying the 1,430-ton girders, this machine broke the world record. Before, the record for the world's heaviest transporter girder was a 900-ton girder in Italy.
To achieve this record-breaking task, the TE1600's 640 wheels are spread over 4 separate vehicles. Joined at the front and back by giant support beams, each vehicle has 160 wheels arranged into groups of 4. The load on each wheel group is automatically adjusted through an integrated hydraulic system to ensure that the weight is evenly distributed at all times.
If a tire pops, other tires next to it can share its weight capacity, so it won't cause the whole vehicle to tip over.
This is very important, as the TE1600 uses the unfinished bridge as an access road across the mudflats. If the girder were to fall off here, it would be stuck in the mud forever. Although separate, the 4 vehicles drive as a single rigid unit. Multiple sensors relay information to onboard computers. The computers use this information to adjust the speed and angle of each of the 160 wheel groups to ensure the 4 parts work as one. The TE1600 can reach a top speed of 4 kilometers an hour when fully loaded. At that speed, it's not going to win any races. But this slow and steady mechanical millipede is set to revolutionize the building of long-span bridges.
This particular design is unique to this particular bridge, and I have to hand it to them. They have done it, and other people will probably use this technique elsewhere for other bridges.
But this monster millipede will need an equally impressive partner if the mudflats are to be conquered completely. And that's when the next machine steps in, or rather, steps out. The LGV 1600 literally walks on thin air to install the girders. Once the girder walker reaches the distant pier, the rear movable leg rolls to the end of the previously installed section. And the front movable leg rolls across the open span. The lifting winches move to the front to balance the walker. And the back leg lifts up. The millipede enters with its load. The back section of the millipede drives forward. The rear leg of the walker folds down, and the winches move back to pick up the girder. Steel rods from the winches are secured to the girder. Once in place, the girder is lifted off the millipede. Walker. Now that the weight is distributed to the front again, the back leg lifts up. The millipede drives off to get another load. And the existing girder is lowered into place. Using this technique, they can install 2 to 3 girders each day. And slowly but surely, one span at a time, they will bridge the giant mudflats. After 3 grueling years, the piles are all in place. Most of the piers are complete. And as the girders are positioned, the bridge begins to reveal itself.
As an engineer, I can visualize the bridge. You can see the columns coming up now. You can see the curve of the bridges there. It virtually disappears into mist. There's a kind of mystery at the other end of the bridge. You wonder where it's going to land.
But there's still a long way to go before the bridge finally comes together. The team will encounter more typhoons. Winds and currents will pound men and machines. But it will all be worth it if they can finally build the world's longest transoceanic bridge.